Johnson Controls has a 140-year history of innovation, creating smarter, safer, healthier, and more sustainable buildings. They are one of the world's only pure-play smart building company offering the largest portfolio of building technology and software, as well as service solutions. All right, everyone, thank you so much for joining us once again on Did You Know? So we're spending some time at the Johnson Controls Norman, Oklahoma facility, and Chris Forth, how are you, sir?
Very good.
Is joining us today to give us an inside look at the advanced manufacturing that we have here, a history of manufacturing right here in the United States since 1972.
That's right, Cliff. We've been in this facility. It's changed owners over time from Westinghouse and Borg Warner. Johnson Controls bought this facility in 2005. But it's always been some type of HVAC manufacturing from the beginning. So,
yeah, and the thing that I'm sure we're going to see a lot of is changes and innovations that have happened in the manufacturing, not just the equipment. You know, we talk a lot about how our industry is changing. We have so much new inverter technology coming to the forefront. We have changes of refrigerants from R410A into R32 and R454B, our A2L generation of refrigerants. But at the same time, we also have companies like Johnson Controls that's really investing a lot into the sustainability of their manufacturing. And it's really interesting the things that have changed here and adapted along with the equipment technology. And so you're going to get an inside view of so many of these things. We're going to talk about training, we're going to talk about manufacturing, sustainability, and just a lot of opportunities to see what happens on the manufacturing side that most of us never get a chance to see.
yeah, you'll get to see a lot of manufacturing, but we also this is our design center for all our rooftops. So everything we build here from 3 through 150 ton equipment, some of which you see, all right here in the U.S.
Yes.
And it's residential. It could be a small commercial rooftop, all the way up to 150 ton rooftop and large commercial splits as well.
Very cool. So we're going to have a lot of adventure. So we appreciate you joining us, and let's start the tour of this wonderful place.
All right, ready to go.
The 900,000 square foot Norman, Oklahoma facility serves as Johnson Controls' flagship site for the research, manufacturing, and testing of HVAC rooftop units produced under the Johnson Controls, York, Luxair, and Coleman brands. So we're spending some time with plant manager Rob Beitelman. Rob, how are you, sir?
I'm doing well, thank you.
So one of the things that we know Johnson Controls has invested a lot in the facility is automations to be able to particularly make panels that eliminates that potential for human error. I know in the field, sheet metal bending is not the easiest task in the world. A lot of math, a lot of very precise measuring. When you introduce automations and robotics, we have that ability to remove some of that and to make things much more precise. Tell us a little bit about what we're doing here with this machine.
All right, so what we have here is a Amada ATC. It's fully loaded by a single arm robot. And you can see right here, it does exactly what you said. It does take away the human element of error.
Yeah.
This is a very complex multi-piece brake part that you see here. And it does take away that human element.
Sure, so it's just starting with a flat sheet, goes through and actually recreates all of the movements, all of the bends.
Exactly,
yeah. I'm curious, I wonder how many pieces a day this thing can actually flip out.
Well, it doesn't stop, so that's a good thing. So we'll do, out of this here, we'll probably do 2,000 or 3,000 pieces a day.
Really? Wow. Yeah.
Off this one particular cell.
Couldn't imagine the poor human trying to do that and wearing their fingertips out.
Right, definitely.
All right, very good. Thank you, sir.
All right, thanks.
A series of advanced upgrades have redefined efficiency at the Norman plant, including a high-performance central utility plant, a next-generation compressed air system, and plug-load controls. Water conservation measures alone are set to save an impressive 3.5 million gallons of water annually. Additionally, the installation of a 1.56 megawatt carport solar photovoltaic system, coupled with vehicle charging stations, has established on-site renewable energy generation. By adopting energy-efficient technologies, decarbonization strategies, energy transition practices, and renewable energy integration within its own operations, Johnson Controls exemplifies the solutions it provides to customers, setting a benchmark for sustainability in the industry. Okay, Chris, so we've just manufactured our U-bins. As Ty said, we've got our U-tubes for our YouTube channel.
Copper. Yep.
Right.
Yep.
So after we've made our return bins, our full lengths of copper, what are we going to be doing in this stage?
So what we do here, Cliff, is we take the U-bins, these long copper extruded tubes, and we're going to insert them. We're going to thread the fins, the aluminum fins, these tubes through that. And this machine you see behind us is called an expander. So it takes a metal bullet, a die, if you would, and runs it all through the
whole length?
The whole length of this, all the way up until the end sheet, and expands that outer diameter, right? So that it makes solid contact with the aluminum fin, which you have to have for good heat transfer.
So when we see the aluminum that is actually flared out onto the copper tube, that's because we've internally expanded that copper to the aluminum.
Some of it is in the fin die itself,
sure,
but certainly this has to be expanded a certain
thickness,
engineered ratio,
right?
Because you can't have any gaps.
Yeah,
without
absolutely.
the gaps, you don't have efficient heat transfer.
Yeah,
exactly.
100% makes sense.
So that's what we do. This is the older school. I would say this is a more traditional design. We also, you saw a while back, the microchannel, right?
Absolutely.
That does the same type of heat transfer in a different way.
Gotcha.
But you'll see most of this on the indoor evaporator.
Yes.
And mostly on the heat pump outdoor coils.
Very cool. That's intriguing. I've always wondered how we do that, and here we go.
Yeah.
Very basics.
All right.
Thanks. Hey, Chris, forgive me, but Ty says this is going to be a fantastic portion of this video.
Nice one.
He's
nice
always
one,
sharp on those.
Yeah.
So for those who don't know, Ty is actually with us right now. We're enjoying this experience so much, Chris. This is amazing.
Yeah.
You know, as technicians, we never get to see this side of it. So to understand how to fix something, it's always a better perspective to know how it was made, right? And so we're getting to see a perspective that we always wonder, what does it look like? Well, this is it.
Right.
So you were telling me a little bit about the stamping of the fins that we're going to be using for our coils. How do we actually get to that point of being able to attach make our aluminum fins and then attach them to that tubing process we just seen?
That's a great question, Cliff. So the machine you see behind us is called a fin press. It takes a coil of aluminum.
Okay.
It cuts it to width, and then it, with a die that stamps out several hundred per minute, makes this unique pattern that you see here that has a lot of, I'll call it, intellectual property behind it.
For the heat transfer properties.
For the heat transfer.
Oh,
and
absolutely.
the copper tubes we just looked at go through these holes, right?
Okay.
And you can see the little aluminum collar
it's like
here.
A divot.
Yeah, but those fin patterns and waves, if you would,
Yeah.
there's a lot of heat transfer engineering into those. But basically, just like these metal tubes that we're seeing holding this, those copper tubes will go through that, and they'll line up this fin, right? This fin deck, right? And then they'll put the tube through there, expand the bullet that we just looked at.
Inside of that copper tube.
Inside of that copper tube, and that collar height that you see here is very critical.
Oh,
right?
I'm sure.
And you have to have the right amount of pressure, not too much that can cause a failure, but enough that you want good heat transfer. Okay? And you do that in every single hole.
Wow,
right?
That's amazing.
So there is a lot of engineering. Most people look at a coil and go, it's a coil.
Yeah.
They don't realize how much effort and engineering.
Yeah.
There's simulation software, there's actual testing, what we call coil calorimeters, to determine this. And these fins will often be different, in most cases they are, between an outdoor coil and an indoor coil.
No kidding.
Right, because they're different airflows typically.
Absolutely, different thicknesses.
But lots of engineering here. So really cool stuff.
I would have never thought that much engineering into a fin.
Yeah. Yeah,
one little piece of the entire orchestration.
Yeah, and these, again, are all protected with intellectual property.
I'm sure.
We all have our unique designs here. And again, they're optimized for certain airflows, certain configurations, and they'll change by design over time.
Oh, I'm sure, by the thickness of tubing, the diameter of tubing we're using.
That's right.
Oh, wow, that's intriguing.
Right, I think it's really cool stuff.
I do too.
And if you think about this, how many millions of these fins that we make a year? I mean, we can pump out 500 fins in a minute, right? I mean, it's just bang, 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 bang.
Yeah.
If you hear that noise happening, that's what's happening. Each bang of the press, one of these falls onto this holder, though.
It's amazing.
Despite all the comprehensive upgrades, operational continuity was maintained, enabling the plant to meet its ambitious 80,000 unit annual production target. This seamless integration underscores the team's commitment to both sustainability and productivity. Johnson Controls leveraged an infrastructure as a service financing model, ensuring the Norman plant's upgrades were achieved without impacting its capital budget. This approach enabled critical investments in other business priorities while modernizing the plant's operations.
Okay, Chris, can you explain what we're doing here? I know we've inserted our tubes to the fin assembly.
Right.
What is this monster doing?
So this is a coil expander,
Okay.
and what they're going to do is use the bullets, if you would, the dies here.
Yeah, those real long rods.
Those real long rods,
Okay.
great. That's an accurate description, to expand the copper tube into the aluminum fins.
Okay.
That will give you the heat transfer that you need.
Okay,
right? That
so
talked
we were
about.
really specific on the manufacturing of the like almost a grommet on our aluminum fin, every fin.
Yeah,
Now
that's
we're
right.
going to expand that copper to meet a very critical tolerance for our specific heat transfer.
Yeah, within several thousand. So you'll see the tubes kind of line up. See their contact,
Oh,
they
yeah,
go
yeah.
slow at first, and then all of a sudden you'll see it
look at
come
that.
down, right?
Right.
Now they're going down in through there, and in a minute you'll see, here we go, they're lowering that, and you'll kind of see in a minute how that goes all the way to the bottom and then back up.
So every single hole in every single fin is expanded.
That's right.
Wow.
Yeah. Yep. So now you have a finished coil.
Yeah.
It'll have to have the header added right in the U-bins, right, and so
Absolutely.
forth. But you basically have a finished copper
A
tube
finished
aluminum
heat
fin coil.
exchanger. Yeah.
That's right.
I love this.
All right.
With more than 100,000 experts globally operating in more than 150 countries, Johnson Controls' industry expertise is what makes them the world leader in building technologies. What sets Johnson Controls apart is their ability to deliver true life cycle solutions tailored to meet the needs of businesses of all sizes, industries, and geographies. The robust experience and scale allow them to guarantee long-term outcomes, often with service contracts extending up to 30 years, creating enduring value for their customers.
So Chris, in many manufacturing facilities, they'll do sample testing on products
Right.
to verify that everything is, quality assured.
Right.
Right. So tell me a little bit about the testing process here at your facility for your equipment.
Sure, Clifton. First of all, 100% every single unit goes through what we call auto test.
Okay.
It checks all the Unix functionality, cooling, heating, and I say heating. If it's electric heat, we check the resistance. But the gas, you can see the exhausters, they fire
Yeah,
the gas.
it's a live fire.
The live fire. They check for continuity. In this case, you can see an economizer. They
Sure.
check economizer functionality. And they go through this multi-unit checklist to make sure everything's functioning as it leaves the factory. So no sample here, 100%.
100% testing.
Yeah.
That's a lot of investment.
It is. I mean,
Yeah.
you can see with the line rates we're all running,
Yeah.
it has to be pretty efficient. And if they find an issue, they've got an area where they can troubleshoot it
Yeah,
in that
you
area to
bet.
keep the line flowing. But in most of the cases, right, it runs through compressor, airflow, make sure the fans are running the right way. Like, for example, you'll see kind of in the back here a sail switch.
Yeah.
Like, say somebody put the fan blade, the condenser fan blade on
Absolutely.
backwards,
Could potentially
that sail
happen.
switch wouldn't go off,
Automatically
right? They
detect
would know
that.
it's on backwards.
Right.
So it does basic checks like that for all the functionality, including the controls. So it simulates a thermostat
Sure.
being hooked to the unit. And that way, if you're giving a W call, a cooling call, heating call, it's going to function as needed when you get to the field.
Right. True live fire simulation.
That's right.
Very cool. Thanks.
Johnson Controls is a global force, found everywhere from the world's most iconic landmarks to the local businesses that form the backbone of communities. With a team of over 100,000 experts across more than 150 countries, their expansive reach and scale enable them to deliver impactful results worldwide. Johnson Controls' innovative solutions transform spaces into efficient, resilient, and productive environments. tailored to the specific needs of each region and industry. Proudly committed to building a better future, Johnson Controls is shaping the world, one building at a time.
All right, everyone, thank you for joining us. We're spending time with Steve Maddox with Johnson Controls, and we're in the recently built test facility. And so we looked at our previous testing site where we were doing horizontal testing of our package units so we can simulate indoor and outdoor conditions. Now we're actually in a new facility where you can simulate exact installations with rooftops being above, your duct distribution below. Right. And so tell us a little bit about this, the psychrometric testing that you do here.
Yeah, so these chambers are set up in an over-under configuration, which really simulates how a rooftop, commercial rooftops installed.
Yeah.
Downflow duct orientation and a lot of capability in the airflow, the temperature range that we can test on the product. So we can simulate the new cold climate heat pump conditions, which is very important.
Yeah.
And the over-under arrangement, like I said, gives us a true representation of how the units apply typically in the field.
Okay. Yeah, we spent a lot of time talking about the cold climate heat pump challenge. So we work pretty extensively with the DOE, a lot of P&L discussions. Right. And so when we talk about this next generation of equipment and the capabilities that we're now looking at in heat pump technologies in our RTU systems, you can actually do that testing here at the manufacturing facility.
Absolutely. Yeah, the rooms are all capable of testing down to very low temperatures and holding those conditions.
You ever try to make snow?
We do not make snow in these facilities, no. We do have a facility that at our other Wichita factory that we can
introduce moisture into the atmosphere.
We do, and we can test some of our smaller rooftops there.
So approximately what are our operating capabilities, low temp and high temp, for these scenarios?
Yeah, these rooms can go down to about minus 35.
Really? Wow.
And it depends on how much capacity of unit we put into the facility, but they're capable of low temps.
Yeah.
And then we can go up to 125 or 130 if we need to.
Right. More than capable of actual installation.
Yes.
Test.
Yeah. It very, very extreme conditions and not typically where we would see products operating.
Okay. All right. Thanks for your time.
Sure.
So we are in the test facility, particularly for the heating side. Now we have 16 stations that are vertically designed so that we have half of our system on the second floor, half on the first floor. Can you tell me what we do in this lab with these 16 different stations?
Yeah, these stations are set up to do all the heat side testing. So it's electric heat, gas furnace work, all done here in the facility. And they're, like you said, they're set up for downflow, or they can do side flow duct orientation as well.
Sure.
Heating capacity, we can test over 1 million BTUs of gas heat capacity and 250 or so kilowatts of electric heat.
So you're telling me that before we get to this stage, we'll actually do simulations. So we'll go through a variety of simulations of what could potentially work best, and then we come out into the lab and we actually experiment with that and try different options, trying to gain efficiency or trying to adapt scenarios that we already have mapped out.
Right. We go through multiple design iterations to try to optimize the performance of the system before we actually put it into the lab.
Sure.
And before we build the prototypes, and then we're really validating that. And if we see differences, we'll modify our simulations and rerun some of those. But and then of course the other part of testing is doing our performance certification as well as the safety testing and certifications.
You bet. Sounds like a fun job.
Absolutely.
Take something that's good and try to make it better.
That's right.
All right. I like it. All right. Thank you.
Good.
Now with this facility, we actually have 10-ton and 15-ton cranes that are stationed through the center design of the building so that you can actually maneuver the equipment. Rooftop units, how large of a rooftop can you test in this facility?
Well, the largest unit that we can test in here is 150 tons.
That's a big boy.
It's a very big unit. And But we did have to get creative on when we built the facility on how we handled the equipment to basically lift it and place it into the test rooms, which is why the cranes are in place.
Sure. So you can bring them through the center aisle and position them on either side, depending on what we're going to be testing for. So you have independent chambers that we can set the equipment in both here and over on the lab side as well.
Yes, that's right. On this side for cooling testing, and then also in the heat test area.
All right. Very intriguing.
Yeah.
The plant includes a 2-story, 52-foot high testing lab, roughly the size of 1.5 football fields. The extensive laboratory offers an environment that allows Johnson Controls to conduct on-site complex development, regulatory compliance, performance, safety, and reliability testing, including the ability to test a 150-ton rooftop unit in climates ranging from minus 35 degrees Fahrenheit all the way to 130 degrees. The labs were designed with a modular construction in mind, allowing flexible testing for a variety of different system applications. This adaptive design ensures accurate, real-world testing to meet high-quality standards across diverse products.
So to show some of the vastness of the test facilities and the test chambers that you have here, we wanted to show a little bit of scale. So this test chamber is actually designed for up to 150-ton systems to be analyzed, evaluated, take all of our psychrometric measurements off from it. And you don't have just one of these.
That's right. We have invested for large rooftop testing, so we do have a 150-ton test room.
Yes.
And then we have a couple of smaller 60-ton test rooms that do both all the performance testing, heat pump, cooling, and we also have a large sound test room for large rooftops.
Oh, yeah, absolutely. I hadn't even thought about that. So we're going to show a little bit of scale, and we're going to walk back up just so that you could get an idea. A lot of people have bragging rights about having their own barometric and psychrometric test chambers, but I can't say that I've ever seen one that I can put a house in.
It is large, yes.
Yeah. So hopefully you get a perspective. We're looking at 20-foot ceilings approximately.
Yes. Yeah, about that.
Yeah, so quite the facility for testing large pieces of equipment. And as we start moving into new technologies, you'd mentioned we're even looking at sound. So not just the efficiency, but we're also looking at, what is the quality of the piece for many different aspects.
That's right. Yeah, we are able to actually test up to 60-ton sound tests, which is pretty impressive for that large equipment.
Yeah, for sure. All right. Well, thank you for this. We really appreciate it.
Sure.
So when we speak on audiology, I'm a big fan of a quiet space when we're doing our recordings. Ty and I both have studios that we've built specifically for audio quality. And in doing that, it's a big investment to understand the space that you're working with and then to be able to do high-end audio recording. And that's really what we're doing in here is we're testing the noise of our systems in actual conditions. And so we have an entire facility dedicated to providing a quiet space for our HVAC units to be tested in. So Chris, I know sustainability has been a very important factor here at Johnson Controls. Now, Johnson Controls provides efficiency and provides monitoring and controls and equipment for structures all around the world. You've actually implemented those practices into your own manufacturing facility. Can you tell us a little bit about some of this investment?
Yeah, just what behind us here, Clifton, is new air compressors. So these were all part of the broader initiative sustainability here at the Norman, Oklahoma factory.
You bet.
So we have new air compressors, highly efficient, right? Brand new. Solar, wind, and you're going to see new chillers here in a minute. So we've got all the above, all that managed by our OpenBlue digital solutions, including our fire, life, safety, managing this building.
Right.
So basically in this Norman facility, we've got all Johnson Controls suite of products here.
You bet.
And, we're talking it, we want to walk it, right? So this is our example of doing our own facilities as a showcase of how sustainability is also good for business.
Oh, absolutely it is.
Yeah.
Excellent. Thank you.
Yeah.
The plant modernization project is expected to generate $960,000 in annual savings, reduce emissions at the site by 43%, and create a blueprint for global organizations seeking to implement building modernization projects that bring value to owners, employees, investors, and communities. We are so grateful for the opportunity to explore the Johnson Controls Norman, Oklahoma facility, and we encourage you to learn more about Johnson Controls at johnsoncontrols.com.